I welcome you all for today's session of projection of solids. Today we are going to take up with a hexagonal prism. The problem statement goes like this. A hexagonal prism, 25 sides of base and 50 axis length, rests on HP on one of its corner of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Full stop. Draw the projections of the prism when the axis of the prism is inclined to HP at 40 degree and to VP at 30 degree. I read the problem. I have a hexagonal prism of 25 sides of base and 50 axis length, which is resting on HP and one of its corner of the base. So I can understand the two solutions of the two question. That is where it is resting. It is resting on HP, and how it is resting. It is resting on the base corner. It is resting on the base corner. So I understood that I should have a corner on my right hand side of the diagram. So to begin with, I know it is a hexagon, and when I see it from the top, it looks like a hexagon in the top view of 25 sides, and the axis length is 50 So what I'm going to do is to begin with the solution. To begin with the solution, I'm going to draw the XY line, then write vertical plane and horizontal plane, that is VP and HP. Then I need to have a corner on my right hand side. I'm going to draw a hexagon in such a way that I get a corner on my right hand side. So I have got a corner on my right hand side and I have drawn a hexagon. And to draw this hexagon, I'm going to draw a circle, then cut this down and then join the lines, and it is very easy to draw the hexagon. Once I get a corner on my right hand side, I'm going to name it as we have taken up with the previous classes. The top base, I am taking it as P, Q, R, S, T, E, and A, B, C, D as the bottom base. The top base is P. This corner, I'm going to name it in anti-clockwise direction. It is Q, R, S, T, and this is U. And the bottom base, I'm taking it as A, B, C, D. So it will be in the bracket A, B, C, D, E, and this is F. Whatever the top base I'm going to name, that will be outside the bracket, and whatever the bottom base I'm going to name, it will be within the bracket. It's not necessary to take A, B, C, D, E, F, G, H like that. I can take 1, 2, 3, 4 like that, or I can take A, B, C, D for the top base and P, Q, R, S, T for the bottom base. It depends on the drawing what we are doing. It depends on us. Now, when I see this thing, whole thing from the bottom, and I'm seeing it from the bottom, four points are visible. That is A, B, C, and D. These four corners are visible. So it will be outside the bracket. So this point is A dash. This point is D dash. And this point for me from here, it is C dash. And this point, this corner is nothing but B dash. Now E is merging with C and F is merging with B. So I'm going to write as F dash within the bracket and E dash within the bracket. and also I know this is O1 and O2. O1 is the top base, O2 is the bottom base. So this will be nothing but O2 dash. On the similar background, I can see P, Q, R and S. These four corners are visible. T and U are not visible, so they will be within the bracket. So I can write this as P dash, then Q dash, U dash, this says R dash and E dash, and this says S dash, and this is O1 dash. So this point is P dash, Q dash, U dash, R dash, E dash, S dash, and O1 dash. It is nothing but P dash is visible, Q dash is visible, so U dash is within the bracket. R is visible, T dash is within the bracket, and S is visible, so it is outside the bracket. So the same thing, everything I have written it here. Now I have a axis inclination here. I have an axis of 40 degree. I have an axis of 40 degree here. Now, since I have a rectangle here, this is my rectangle in my front view. Say suppose I have got a rectangle like this in the front view. And I have this axis in between. And this axis, it is resting on this XY line. I have this axis is making an angle of 40 degrees. This axis is making an angle of 40 degrees. So what I do is I cannot draw this axis like this. Instead of that, I need to draw my baseline which I have already. That is this baseline from here to here. Say this is A and this is B. I need to draw this A and B here on this line. A and B I have to draw in this line so that the axis automatically, I'm going to lift this rectangle in such a way that the axis will be automatically 40 degrees. It will be automatically 40 degrees. So for which this is 90 degree, and I take this as a rectangle triangle. That means inside angle of a rectangle should be 180. So 90 minus 50 means what? This has to be 50 degrees. This angle, the unknown angle which I don't know, is 50 degrees. So what I do is, if I have, this is my XY line. If I have a XY line, first is what? Holding some point. What I do is measuring from this A and B, measuring here, I just draw a 50-degree line first. This is my 50-degree line. Then I measure from here to here, whatever is the distance, I cut it down, and from here to here, whatever is the distance, I cut it down. Then this will be my axis line, this will be my rectangle which I need to complete. Then when I extend this, this will be automatically 40 degrees. I'm going to just lift it with respect to the base. So in that case, I know that I have a rectangle here that is 90 minus 40 is 50 degrees. Now I have to know with respect to the base, I have converted the axis inclination to the base inclination. Now I'm going to draw this. So coming back to the previous problem, what we were taking down, this is my problem which I'm going to convert it into the x base inclination. So the axis they have given it as 40. I'm going to draw it with somewhat with 50 degrees. I'm going to draw somewhat with 50 degrees. I'm going to convert the base. I'm going to draw a line of 50 degrees. At 50, this is my 50 degree. Now what I do, I measure from D to A dash. What is the distance? It is 50 mm. From D to A dash, it is 50 mm. I cut it down. Then D to B dash, what is from A dash to B dash, what is the distance? It is something around 1.4. So from A dash to B dash, it is something around 1.4. From B dash to O dash, it is 1.1. So from here to here, it is 1.1. And from here to here, again, it should be 1.1. It is 1.1. That means I know this distance again. So I have got all my four points, that is from here to here, that is this point is D dash, this point is A dash. I have measured it with the scale. You can measure it with the compass, then just cut it down on these lines. Once I know it, I need to draw a 90-degree line. I need to draw 90-degree lines here. So I'm going to draw 90-degree lines here. So that I don't miss anything with respect to the problem. And the length of this is 50 mm. So directly I draw it with 50 mm. This is my axis. So I draw a axis line here. Once this is done, I just close this down and do the naming whatever I have on my front view. So this is B dash, F dash, O2 dash, this is C dash and E dash. This point is P dash, it is Q dash, U dash, O1 dash, and this is R dash into E dash, and this is S dash. Once this is done, I need to project this sideways, which I'm going to do it. This point also I need to just take it sideways, and then this. Then I'm going to project the bottom base first. I have projected the bottom base. I need to place the points. This is A, this point is B, this point is C, this point is D, this is E, and this is F. Similarly, I'll take it from the top base. So this is my point P, this is Q, this is R, S, then I have T, and this point is U. The first thing is complete my top base, P to Q, Q to R, R to S, S to T, T to U, then U to P. Okay. So I have completed my top base. Then I am going to complete the outside line which comes along with, so Q to B, B to A, and A to F. This is the outside part, and then this whole thing. So first I'm drawing the top base, then the outside points, whatever I have along with this, I'm just going to convert it. Then see the lines going out from this corner, that is D. From this corner, I have D to C, D to E, as well as D to S. So I have D to C, I have one line which is dotted. Then I have one more line from D to E which will be dotted. And then I have one more line from D to S which will also be dotted. So D to S will be also dotted. And then I have A to P. A to P is a line which is the longer edge here. A to P is this line which will never be dotted. So I'm going to join A to P. So A to P, I'm going to join it. So I have two small lines and one large which is dotted. But this line will be merging with A to uh, P, where I don't get dotted in this portion only. In the other line here I get dotted, as well as this is dotted. Dotted means nothing but it is my hidden line. Now I need to place this rectangle, that is 1, this point, this is 2, this this is 3, and this is 4. This whole thing I'm going to place here along with the axis inclination. Now the main understanding for me, this is point O1 and this is my point O2. O1 and O2 is the axis length. When I see the axis length here, when I see the axis length in this position and see the axis length in this position, it is varying. It varies. The axis length in this position and the axis length in this position, it varies. So I need to check when it is varying, I need to go back to the problem and check whether I have appears to be or no in the question. When I come back to the question and read the question, I see the axis inclination to VP, it is 30 degrees, and I don't have anything other than that with which is appears to be in the question. When I don't have appears to be, and the axis is length is varying here and the other way, that means it is a locus problem. So what I do is I draw a line of 30 degrees here to draw the locus. So a, a line of 30 degree. If I'm left out with the space, and I'll just coincide with the diagram here where I'm going to draw a 30-degree line, where I'm going to draw a 30-degree line from this end. So now I'm going to draw a line of 30 degrees, then measure the original length of 50 mm somewhat here. The original length is 50 mm. This is my original length. I draw the locus of it. I draw a locus of it. So this is my O2 and this is my O1. Then I measure it from O2 to O1 here. When I measure, it is something around 3.8 in this. So again, I'm going to measure it with the compass and cut it down here at the locus, that is at 3.8. So when I cut it down, this is my new point of O2 and O1. I just extend it down. So this is my O1 and this is my O2. Now what I do is I need to place this rectangle, that is 1, 2, this point is 2, 3 and 4. Along this axis which I have drawn now, that is O1 to O2. So I know the distance from O2 to A. I know this distance from O2 to A. So I measure along the same line, it is 1.6. Along the same line, I measure it down at 1.6. I cut this down. Similarly, it will be the same distance at 1.6 and cut this down. So this point is nothing but, for me it is A, and this point it is nothing but it is S. Then what I'm going to do is draw a 90-degree line. With the new point A as a center, draw the 90-degree line. Draw the 90-degree line. With the new point as center, draw the 90-degree line. So with point S, I'm going to draw a 90-degree line, and with this point as S, I'm going to draw a line here. Once I know that, I need to complete this rectangle. So from A to 2, I know the distance. From this S to 1, I know the distance. From S to 1, I know the distance. It is 2.1 in this case. For me, it is 2.1. It might vary for you people when you measure it with exact scale. So from S to 1, S to 1, it is 2.1. So from S to 1, it is 2.1. The same will be everywhere. The same thing it will be everywhere. So I'm going to measure 2.1 everywhere and I'm going to place it down. So from here also it is 2.1. Once I know everything, I just close this rectangle. I'm just going to close this rectangle. Then name these rectangles. This point is 1, this point is 2, this point is 3, and this point is 4. I'm going to name these rectangle with the namings what I had given earlier. And this is the easiest method what we can place this whole thing on these lines. Now in between 3 and 4, I have 4 points. 1, 2, 3, and 4. That is B, C, Q, and R. I have 4 corners in between 3 and 4. In between 3 and 4, I have 4 corners where I'll measure each corners. It is 2.8 from this end. It is 0.8 from this end. So from this end, it is 0.8. The same will be from this end, it is 0.8, that is point R. So I know point R now, as well as I know point B. On the similar ground, in between 2 to 1, the same, it will be the same 0.8. So it will be the same 0.8 distance from here to here. As I have taken the calculation, so this will also be 0.8. That means I know point B as well as point T. Now from this end, so from this end I need to know point C. From this end I need to know point C. So from 3 to point C I measure, that is corner C, that is 2.2. It is 2.1. So from 3 it is 2.1. So it will be the same from 4, that is 2.1. It will be the same from this corner 0.1, that is 2.1. And it will also be the same from this corner, that is 2.1. That means again I know 4 points, that is corners, that is E, this is U, and this point is C, and this point is Q. Now only another point I should know as D as well as P, that is this corners, these two corners. So from O2 I can measure point D. From O2 point D I can measure, it is in this case 1.7. From O2 I measure along the line, it is 1.7. Similarly from O1 it is 1.7. So I measure it. This point, this corner is nothing but D, and this corner is nothing but P. Once I know all the corners, I'm going to join it with those lines. That is from A to B, B to C, then C to Q. I have Q to R, then P to Q, R to S. I finish the outside corners first. S to T, T to U, and U to P. Then these outside corners U to E, E to B, and back to A. These are my outside corners. Then from D to E, I have a dotted line here, as well as D to C, I have a dotted line, as well as from P to S, I have a dotted line here. I'm just eccentricity. I'm doing it just to understand. But you have to, if you have drawn a solid line, you need to erase this line, then draw a dotted line. I have drawn it with a pen, so I'm drawing it on the other side with small eccentricity. So you don't do it. It should be on this line only. If you have drawn it with the pencil, you have to erase, and it should be a dotted line here. Once this part is done, the other remaining part is I have to project it upwards, then I have to project sideways, complete this whole thing. This part from 5th to 6th diagram will be very easy, where I'm projecting the bottom base on top, and this is sideways from this end. I'm going to project it sideways with the bottom base as well as with the top base. I'm going to just do the projections and just close all the points and understand. And with this point only the dotted will be the, from this end if I'm seeing the line which is the farthest corner here, it is B, and the line going out from B will be dotted in the sixth figure. That is all when it is compared with. So we are left with time till we do complete it. We'll complete this. So I have point A from here, and A from the other end. This is A. Then I have B and F. Then I have C and E. So this is A dash, this is B dash, this point is C dash, then I have D dash here, this point is D dash, E dash and F dash. So I join all the corners. Similarly, I'll be having the another hexagon which is coming from the other end, where I have P from here and P from here, then Q from this end and U from this end. Then R from here, and T from this end. So I have T here as well as R. Then I have S. So I have all the 6 points. This is P dash, Q dash, R dash, S dash, T dash, as well as U dash. So I join all the lines. Then complete it from P to A, then Q to B, then E to S to D, E to T. Then I have from R to C as well as C to everything I have drawn. Now only thing is I need to find out the dotted lines. It is nothing but from this end, the farthest corner. It is not this corner which I have, that is P, Q, R, S, T and U. I'll be having out of these, I'll be having one. It is not A, it is not B, it is not C, nor D, nor E. The farthest point corner is F. So the line going out from F will be dotted. So the line going out from F is F to E dash and F to A dash and F to U dash. So the line going out from F is all these 3 lines. Again, it is in Y shape, 2 small and 1 large. So with this, we complete the problem where I need to do all the dimensions. It is very must. This is 40°. Then I need to do this part. It is 25 mm. So I need to draw and write 25 mm like this. Then I need to do the dimension of this axis, whatever is